my demonstration of knowledge from our lava lamp lab. When we first started our lab, we had our cup and we had our water filled up about halfway, and then we poured our oil on top of it, and the oil is less dense than the water, so that causes a suspension. And a suspension is when a less dense or more dense object separates but never mixes. For like example, the oil and water. And the oil and water is a mixture, and because we are taking two or more substances and putting them together, and more specifically, it is a heterogeneous mixture, which is a mixture of it's a combination of two or more pure substances, but they retain their chemical properties because oil and water never mix. This mixture would not be considered a solution because a solution is a homogeneous mixture which consists of a solute and a solvent, but the two substances never create a solution because they never mix because of the suspension caused by the oil being less dense than the water. Then we add 4 droplets of food coloring, and once we add those, the 4 droplets are heavier than the oil, but because of the suspension, the 4 droplets will stay in the oil, and then once the oil gets too heavy, once the food coloring gets too heavy, they'll all drop down and they'll be in the water, and this will be a homogeneous mixture because it is hard to separate the food coloring and the water. Now that we have the colored water and the oil in our cup, the physical properties of the oil and chemical properties have not changed because nothing has affected it to make it change in any way, but the water has physical properties and chemical properties changing. Its physical properties is now that it's blue because it was clear and now it's blue, and its chemical properties is now that it has the color, it has the food dye, it has the food coloring in it now, which changes the chemical properties of the water. In this mixture alone, there are plenty of atoms from the periodic table. For example, in the water is H2O, and that consists of hydrogen and oxygen, and the hydrogen is never by itself. It's always with another hydrogen, so that's why it's H2, and then the O is obviously oxygen. And then in the oil we have so we also have hydrogen, we have carbon, and we also have oxygen again, but we also have another atom called petroleum, and that is a liquid, that is a atom that is mostly used to make oil. Also, in our food coloring, we have plenty of atoms. We have Food coloring is mostly made in a lab, so they use asphalt, tar, diesel fuel, gasoline, or petroleum again, and they're all combined into making the blue food dye. All of these atoms from the periodic table are all created to create different liquids, which is this mixture. Both water and oil are both compounds because they are a mixture which is composed of two or more separate elements. They are also both molecules. They're also both elements. So now we are taking our Alka-Seltzer tablet and we put it into the water. Once we put into the oil and water mixture. So once we put it in, then it sinks all the way to the bottom because it's the most dense thing in this mixture. And it'll be broken up into 4 pieces, and they'll be all over the bottom of the mixture. So when the Alka-Seltzer tablet is put into water, it causes a reaction, and its chemical and physical properties make it so it dissolves and creates a bubbling effect, and those bubbles are full of some sort of air, and it shoots up, which causes the lava lamp effect. Also, when it does that, it's also causing a physical and chemical change to itself. This chemical change it's also affecting the water and oil. Its physical and chemical changes is that it's dissolving and it's putting its chemicals into the water and oil, and it is when the Alka-Seltzer tablet dissolves in the air pockets, it's grabbing some of the water and it's bringing some of the water into the oil, which is changing some of the physical properties of the oil. Thank you. That is my demonstration of knowledge from the Alka-Seltzer tablet lava lamp lab. Thank you. Bye.